Okay, now we're going to go one step further and go from the circuit diagram to the logical function and then to the truth table. Those are the three different ways of representing the same idea. We're now going to show how to go the complete path. Now, we saw in the previous example, this is actually the same circuit that we've seen in the previous two examples. And so we've already seen the function that this represents. And I'm going to write this a little bit over here to the right so we've got room for other stuff on the left. This is going to be A NANDed with B, and that's going to be ORed with C nor D, and that's going to be ANDed with C or D. Now, in order to quickly and easily fill in the truth table, I'm going to need to put this into sum of products form as described in the lesson. So sum of products form is going to need to get rid of all of the long overbars. So the very first thing that I'm going to do is I'm going to eliminate those overbars by applying De Morgan's theorem. So I'm going to see that this is going to be A. I'm going to break up the bar, but then I have to convert the nature of the function itself. So not A or not B is equivalent to A NAND B. And then I'm going to say OR, and now I have to break up the bar over C or D. So this becomes not C and not D. So that was two applications of De Morgan's theorem to break up each of those two long bars because that's the first step in getting it into sum of products form. And then I'm still going to keep the OR and C or D. Now I've got three terms in the first expression and two terms in the second expression. I'm going to go ahead and distribute those. So that's going to generate 6 terms. And so these are probably going to need 2 lines to do this. This is not A and C, or not A and D, or not B and C, or not B and D, or not C and not D and C, or not C and not D and D. Now this is sum of products form. You can see that I have 1, 2, 3, 4, 5, 6 terms. Each of those terms is just the AND of either regular variables or complemented variables, and then those products, those AND functions, are just ORed together. So this is in the form that I can quickly and easily fill in the truth table. So I'm going to take each of these 6 terms one at a time. And actually, I'm going to go ahead and give you a spoiler alert here. There is no term in the truth table that has both not C and C. That's just not possible. So I'm going to say that term doesn't really have any elements in the truth table, nor is there any expression, any row in the truth table that's going to correspond to not D and D. You can't be both a tiger and not a tiger at the same time. And so anytime you have a not variable and the variable at the same time, that term just simply doesn't exist. So I can actually sort of rewrite this as F equals not A and C, or not A and D, or not B and C, or not B and D. And I'm going to go ahead and represent those as expression number 1, or product number 1, product number 2, product number 3, and product number 4. Now it's time to look at the truth table. So I'm looking, first of all, at product number 1. I'll go through all 4 of them, but I'm looking, first of all, at product number 1. I'm looking for not A and C. In other words, what I'm looking for is places where A is equal to 0 and where C is equal to 1. Well, here's the first place that happens is right here. A is equal to 0 and C is equal to 1. And so therefore, that row is going to contain a 1. And just as a notation to myself out here to the side, I'm going to write that it was term number 1 that covered that row. Now, there's going to be other rows where it's not A and C. Here's another one, not A and C. That'll be a 1, and it was covered by expression number 1. Not A and C. Here's another one, here and here. So that's a 1 covered by term number 1. And then not A and C. That's a 1, and that's covered by term number 1. Now, just for clarity, I'm going to erase these circles because they're going to get very confusing. They won't be valid after this first term, but I hope that you can see how I was able to construct that. Now I'm going to look at term number 2, not A and D. So not A and D, I'm looking for this configuration here, 0, and then I don't care about B and I don't care about C, but D must be 1. Notice that A must be 0 because this says A bar. And D must be 1 because the D does not have a bar. So therefore, this is a term, and it's covered by term number 2. Not A and D, let's see, here's another one. Not A and D, that one's already got a 1. Well, there's no problem if it's covered by more than 1. I'm just going to make a note to myself that it was actually covered by both 1 and 2. But now I have to find not A and D. Here's another one. Here's one right here. Not A and D. That's covered by term number 2. And then not A and D. Again, already covered, but it's now doubly covered. For clarity, I'm going to erase those circles. And now we come to term number 3, not B and C. So I'm looking for places where B is equal to 0 and C is equal to 1. Well, that one's already got a 1, but it's now covered again by term number 3 as well. 0, 1. Oh, this one's actually now going to cover all 3 of those terms are going to be satisfied by that one row. I'm looking for 0, 1. I'm going to have to scroll down because the other 2 occurrences are down here. Here's 0, 1, and here's 0, 1. And so both of those get a 1. And they're both, just get a notation. The notation in the circles there is really not part of the truth table. It's just my way of showing my work, of knowing exactly how it is that those 2 rows happened to get a 1 on them. And then finally, for term number 4, I'm looking for not B and D. So B is equal to 0 and D is equal to 1. Here's 1. It's already been, it's not a tally mark. It stays as 1, but then I'm going to make a note. Oh yeah, that's also covered by 4. Not B and D, that's this row. Wow, that row is covered by all 4 terms of this expression. Again, nothing wrong with that. It's just kind of a strange coincidence. Here we have Here we have not B and D, so that's a 1, and that's for term number 4. And then not B and D, that's also covered by term number 4, and that's it. So last thing I'm going to do is erase these circles, and now what you can see is that we've identified every element of the truth table. Notice this truth table has 16 rows because there are 4 variables, A, B, C, and D. 2 to the 4th power is 16. Well, I've covered 1, 2, 3, 4, 5, 6, 7, 8, 9 of those rows. But I've exhausted all my options. There's no other terms in the expression. Therefore, anything that has not already been covered is equal to a 0. So I fill in the remaining 7 rows with zeros, and the truth table is complete.